tell us a little bit about the research that you've been doing in progressive MS?
Yeah, sure. So we've been working on progressive MS for the last kind of 10 years or so. And all our kind of research focus has been on these tiny energy-producing powerhouses called mitochondria. They're really tiny, they're like smaller than a pinhead, but they're so important in generating energy, particularly in neurons. So neurons are a cell type that's kind of been not studied in MS as much as the other cell types, like the inflammatory cells and the oligodendrocytes. So we've been really focusing on the neuronal compartment and identified abnormalities with these powerhouses. So essentially, the surviving neurons in progressive MS patients are struggling to generate energy. And I guess the 10 years of work, we could really summarize it in a way which is kind of unique to progressive MS, where the ability for a nerve cell to produce energy, to supply the necessary energy is decreased. So there's a problem in supply. And at the same time, the damage to myelin affects the nerve fibers or the axons in a way where the energy demand is increased. So you have a combination of reduced supply and increased demand, which kind of makes the progressive MS situation quite unique from an energetics perspective.
And what does the global effort mean to a researcher like you who does collaborate in your own work? How important is it to work with others, such as in the case of the Alliance?
It's absolutely crucial. As you would see from our publications, they really are collaborative publications. So, you can bounce your ideas with other people, you get constructive criticism, and you can kind of use everybody else's strengths to do things much faster than trying to, do stuff yourself. So I'm a great fan of the collaborative approach, which I think is a major strength of the Alliance.
And what is your hope for progressive MS in the near future? What do you hope to see happen?
You know what? I'm pretty optimistic. I think at least at the symptomatic level, I think we will be able to deliver something in the next, few years. Certainly in the next, 5 to 10 years. I mean, that's my prediction at a symptomatic level. And the question is, what does the energy failure in a neuron translate to a person? And one of the questions I get asked all the time is about fatigue. Does an energy failure in a neuron translate to fatigue? And we've been seriously trying to answer that question, and we've developed some models where we put these particular mitochondrial problems in the neurons in mice. And interestingly, these mice do fatigue. So I think this is a very it's a great example of how we may be able to identify treatment for certain aspects of fatigue in progressive MS and also in relapsing MS. So at a symptomatic level, I'm fairly confident that we'll be able to identify treatments. And the next stage really is to sort of prevent or stop progressive MS. That's a little bit more challenging, but I think with this collaborative approach, we've got a great chance.